Is it okay if I keep my camera off?
What are you saying?
Is it okay if I keep my camera off?
Yeah, off. You don't want to come there or what? I mean,
No.
okay, then it's fine. No worries in that. You can keep it off. Don't worry. But you need to, when I ask you, you need to reply the things. Okay.
Okay.
Okay. Fine. So is the screen shared to you? I mean, it's visible.
Yes.
Okay. So now we'll start. Okay. As I have told you that uh, we'll understand today a few topics. Okay. So
Okay.
the first one is speed. Although we have already a little bit talked about these topics, but still we'll go with this as in depth. Okay. I'll give you a sheet. Don't worry about the answer sheet, how many marks you got and all those things. Okay. So
Okay.
we'll discuss later. Not a thing to be discussed. You performed well. Just I want to tell you, you did all of the things were like looks fine. I'll check. I'll observe and analyze and then I'll tell you. Okay.
Okay.
Okay. So now we need to go through speed. So what is this speed thing? So what do you understand from speed? If we have talked somewhat about the speed, what do you say?
How fast you go?
Okay, how
How
fast?
fast a person travels from point A to point B?
Okay, something else?
Mm,
Some more examples can you give? I mean, you can close the YouTube thing there if it's on because the sound is like coming back.
okay.
Yeah, you can on it afterwards. It will be there. Okay, let's understand. Okay, so suppose this is some line here. Okay, and that's a point. So this point is basically initial point. Are you able to understand?
Yeah.
This is initial point, and this is the final point. That's initial point, and that's the final point. Okay. So suppose at time zero, I just started my time. Like you can say, it's a stopwatch kind of thing. I started my timer. It's a stopwatch kind of thing. Okay. So the particle was zero at time equals to zero. I can mark with some other color. I can use this pink. Maybe which color do you like? Yellow, pink, red, green. What?
Red.
Red. So I will use the red color. Suppose the particle was there at time equals to zero. So what happens that at time equals to 1 second, the particle reaches here. And when I have measured this distance, I get to know this, that this was x equals to zero. Okay. I mean, it's like a number line. Uh, Did we talk about x axis, y axis, z axis anywhere? Or you know that?
No. No.
No. So when I say that this is x equals to zero, did you understand what is this? X equals to zero, x one, two, three, four. Okay, just understand like this. Uh, I hope you have seen measuring scale or measuring ruler, isn't it?
Yes.
So
Yes.
it is having some kind of numbers, like it is having some kind of lines printed out there, isn't it?
Mm-hmm.
So can you guess like a normal scale which you have seen, the small one, how much length it's having? I mean, how much centimeters? It's basically 15 or 10 centimeter, isn't it?
Yeah. Yes.
So suppose this position was marked at 1 centimeter, the big one. I mean, it's like this actually: one, two, three, then this five, the one, two, three, four. So it's basically 1 centimeter, and 1 centimeter contains basically 10 lines equally spaced, isn't it? It happens
Mm-hmm.
like this. If you observe it carefully, you will find it out. Okay. So we can
Okay.
all, yeah, we can also see if we go through the Chrome or like this. Let me check. I'm having here. Yeah. So we go through the measuring ruler, measuring scale. Let's go through that. We have, I think we have the online ruler. You can see. Are you able to see the screen?
Yeah.
Yeah. So suppose, okay. So you can see this ruler, isn't it? This the at
Mm-hmm.
the so what's happening is, so you can see. Let's check from. Okay, let me take this screenshot here. This will be good. Now let me reduce the size of this and let's use it for our photos. Okay, it's saved now. Let's go back to our slide here. Yeah. So now we have the ruler here actually. If I tell you, so the ruler is here, isn't it? So I'll use this.
Yes.
Nice. It looks good. Okay, fine. So now what I'll do is this. Let me change the diagram a little bit. So at time zero, the particle is at this position. You can see the zero position. You will call it position. Okay. What we'll say?
Okay.
This is as position. Where the particle is present at a particular time t, it's known as his position. Its position. So write the definition. What's the position is? If we see, position is location of the particle. In simple words, location of the particle. Location of particle. Where it's present. Where it's present. Is it okay? It's very simple definition. Got it?
Oh, yes.
Yeah. Are you having your friends in this? I mean, you have maybe having a lot of friends in the school or here and there, isn't it?
Yes.
Okay, fine. You can recommend my channel. You can recommend my channel to them also.
Okay.
Please. Okay, no worries. So this was the location of particle where it's present. This is, and you can also watch my channel in free time. There are a lot of things, good things also. Good, everything is good only, by the way. I have some vlogs also there. Okay, so this particle is at this zero position. Now suppose what happens, as we have talked in the previous diagram here like this. So what happens is that now suppose at time equals to 1 second, I will use not this color. I didn't like it. I'll use this one. 1 second. So what happens during the time 1 second, particle now is at this position. So if I symmetrically show you this position, it will somewhat, okay, let us assume that it lands at 10 for the sake of convenience. Okay. So
Okay.
this is, I'll say just this is on the scale at position 10 centimeter. Okay.
Okay.
Yeah. So let me tell you, if somebody is asking from you, if somebody asks from you that tell me how much time did it take, actually how much time did it took to reach at this 10 centimeter, starting from zero centimeter? How much time? Tell me.
Mm.
I'm asking you. How much time did it
10
took?
seconds.
What are you saying? I have written it, everything. Observe the diagram carefully. You just observe this diagram carefully. How much time did it took to change its position from 0 to 10 centimeter?
One
How much?
sec.
Yeah, that's the thing, no? Got it? Understood?
Yes.
Clear, 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 clear. So we'll say, as per this explanation, I have given the explanation here, the definition of the speed. So the things which I'm giving you here today, you have to note it down. Okay. The definition of the speed is like this. It says the rate, the rate of change of position, the rate of change of position, the rate of change of position of an object, the rate of change of position of an object in any direction, in any direction. The rate of change of position of object in any direction is defined as speed. Okay?
Okay.
Yeah. So go with that. This is the rate of change of position of any object in any direction. This is defined as speed. Okay. Now we'll check that how the speed is basically measured. Okay. So if we talk about how the speed is measured, it is basically we'll say is speed is measured as the ratio. By the way, Arav, thank you for the class because class is also motivation for me to get up early here. You know what's time here in India? Can you guess time? What's the time is?
6
Yeah,
24,
yeah, right. What's the time there?
8:54 p.m.
Okay. So when you sleep, I mean, what's the time that, like you just go to your bed?
Like 9:30, 9:50,
Okay.
10,
And when your school time in the morning is,
7.
and when it exits, I mean, when the school gets off.
Uh, it's 4:30.
I see. Note down the things when I will tell you. Just first try to understand it. Okay.
Okay.
Because the speed is measured as the ratio of the distance to the time in which the distance was covered. We know what the distance thing is, isn't it? Suppose
Mm-hmm.
particle is at here at A position. Now you understand what the position is. What the position is? It's the location. Okay. So
Okay.
particle at its A position as per your class standard curriculum. So particle suppose it is at A position and comes to B position at a particular time t, covering some distance. We know the distance. What's the definition of distance is covering some distance d meters. So we'll say mathematical definition of the speed will be mathematical definition definition of speed will be distance upon time. Distance will be in meter, time will be in second. So this goes for you. What's the SI unit will be? SI unit will be meter per second. Okay, and that's the thing. Note it down, the complete thing. So first, you have to note it down. This thing. I mean, you can note down any of the diagrams. This or this. Have you noted it down?
Yeah, I have that now.
Okay, good. This definition, speed.
I have that.
What are you saying?
I have it.
Okay, I have it. This one,
I'm writing.
you understood it. What does the ratio means? Ratio, you know the what's the two things are if they are having the ratio. It's like this. Suppose if I say 2 divided by 3, 2 is at the numerator, 3 is at the denominator. We'll say it's 2 ratio 3. Is it okay?
Okay.
Yeah. So distance we already know that it's basically the path length covered. Okay. Time we know. So when we divide distance by time, we get speed. Okay.
Mm-hmm.
Fine. Note it down. Today we'll go in depth of this. Okay.
Okay.
Arif?
Yes.
Okay. So let's proceed.
Yeah.
Okay. Before, see, that's fine. We have the physics class, but it's not just teaching you the physics here. Okay. So I just want to tell because you're having a lot of journey now. I mean, it's just in which class you are?
Eight.
Yes, eighth class. And what's the curriculum? I mean, we have here like CBSE, we have here like ICSC. What's the curriculum like? IGC, IB? What's there in your school, by the way?
I don't know.
You don't know? Okay, that's fine. No worries. So, okay, I will tell you. I'll give you few things you must understand. See, it's not just about physics here. Okay, I'm just. I just wanted to tell you something like how to be a great like and get a success in class. Okay, get a success in your studies. It's fine.
Yes.
Yeah. So how you can just for a few minutes, don't worry, how to be a successful student. How to be a successful student. It's very important. I mean, it's not just for physics. If you apply this technique in any of the subjects, any of the subjects, I mean, any even not just in the subject, in any of the parts of your life. I mean, if you apply this thing, it will benefit you. Even you can call it as like condition for success in studies or being a good student or subject. If you want to achieve success in a particular subject, say physics, or your studies, your education, maths, throughout your journey in education, you keep this thing, although we are like learning all the time, physics, maths, English, etc. Is it okay?
Okay.
Yeah, so first thing is this: you must very good be very good at your subject. Okay, so to be very good in physics, what do you need to do? You need to do you need to work hard. You need to be you need to be at the practice mode. Again and again, you need to practice the things. Then only you can be good at it. Okay.
Okay.
The first thing you must remember this. Keep in mind, like always, that that's the first thing you need to do. Second thing is that you must be not lazy. Not lazy. If you want to achieve success in subjects, studies, education, because now you are at the education mode. Okay, you're in the education. Your profession is education, by the way. So for success in that, in your school, getting the top ranks, getting recognized, for that you need not to be lazy. So without any laziness, you need to be working very hard, practicing again and again to be very good at your subject. Okay. not to be lazy. Okay, is it okay, Arav?
Okay.
Yeah, not to be lazy. And the third thing which you must remember is that you must be this, you must be not lazy. Yeah, you must also know that I mean you must be thinking it's not must be like this. You are just doing the things. You must be know like you must judge also. It's very important. Judge what that what is good and not good. Okay, I can write like this. I will say you must judge what is right and not right. I mean, suppose you are solving some physics problem. Suppose I give you a numerical, okay? A physics numerical, say based on distance, displacement, speed, velocity. So you must have that ability, or we can call it as like somewhat like this power ability, whatever. You must have that ability that if you're solving the numerical, you must know that am I going right? Am I applying the right formula? Am I doing the right mathematics? Is my way right? Am I applying the perfect concept? So that comes again by the same chain. That is not being lazy and working hard in a practice mode. Okay. Last thing which is required for this is you must have the management ability also. So you must know that how to manage this. You are not just studying physics. Even if I call it for the physics, you must know that which chapter first I must study, which chapter I must not. And if even it's for like other subjects, like if you're having the school exams, you must know that the physics exam is at this time, chemistry is at this and this. So at science is at this, maths at this, English. And so I must know what I must study, how much I know, how much I don't know. So this everything comes basically, everything is connected. So it comes when you have this comes when you have this comes when you have this. So ultimately, you must remember all these points to achieve the success in your education. That's a kind of guaranteed blueprint. What I'm saying, you understand? Are you able to understand? Hello?
Yes, here.
Yeah. So these things, if you keep in mind in all your classes, like you are in the eighth class, ninth class, 10th class, you'll be able to achieve the success. Guaranteed. It's guaranteed. Okay. I mean, nobody can decline it. It's guaranteed. Okay. Now we'll proceed next. Okay. So, okay. Let me ask you numerical here. Numerical number 01. Suppose particle is at A point. So
Okay.
there is a point named, say, okay, not I'll not write this B point. This is a C point, and that's B point. And suppose this is total path length is 100 meter, and B is middle point. If particle reaches from A to B in 50 seconds, find speed, solve it. Hmm.
2 meters per second.
Okay, we'll check it. Let's check it down. Let's check it. Okay. Solution. Okay. Let's go through the solution. Is the color visible to you? Is the green color visible to you, Arav?
Yes.
Okay, fine. So let's go to the solution. We know that we've already started just a few minutes before. Yeah, this thing. So speed we know is equals to distance upon time. So we know this thing that from A to B, it's a middle point. So if it's 100, this will be how much? Tell me. What I must write here, how much distance this will be from A to B?
50.
Yeah, nice. So this will be 50 meter. Time we already are having 50 seconds from A to B. So it takes basically 50 seconds. So 50 seconds, 50 meter, 50 seconds. So your answer is wrong. So it's what? 1 meter per? No. Actually, what happens in this? We have the distance from A to B is 50 meter. But 50 second is for what? From again, it's from A to B. Yeah, I mean, it's fine. So answer is 1 meter per second. Arav, you told me 2 meter per second. Why?
Oh, because I divide 100 by 50.
So this shows what? So did you understood? I mean, you knew the numerical, you knew the formula, you knew the approach, but still the answer was wrong. So you know what's the reason behind that?
No.
Yeah, the reason is if you go through all these 4 points, this thing, you didn't judge it right or not right. You didn't check it. So when you are seeing reading the question, we must read it very carefully. Am I doing right? I have okay. So you read it. Now you started solving it. Okay, formula and then okay, 50 meter. Okay. Then it's 50 meter and then okay 100 meter and divide by 50. It's two. Not don't do like this. Even if after reading the question, you must check. Am I going right? Am I going wrong? Is everything fine? Got it?
Yes.
Yeah, nice. So now we'll go. Now it's the theoretical part. So keep your either note it down fast or like I'll give you the book, this notes. Okay. So
Okay.
types of speed. Now just keep your eyes on the screen. Types of speed. So basically we have, let me put this thing here. Types of speed. So we have basically four types of speed. Uniform speed. We have variable speed. We have average speed. We have instantaneous speed. Okay, now we'll talk about the uniform speed. Okay, so what's the uniform speed is?
Yes.
We know we have studied this, Arav. We have studied the uniform. This variable is also known as non-uniform. We have studied the uniform and non-uniform, I think so, if you remember. What the uniform was? Can you check in the notes? So when object covers equal distance, yes, tell equal distance in equal interval of time. Okay?
Okay.
Yeah, we studied that example. If you see, if we go back, if let us go back in the yeah, so see uniform, non-uniform, we checked it. You've seen this thing in the previous sessions. The speed is of two, uniform, uniform. I told you, Shinchan moving 2 meter 1 second, 1 second 2 meter, again 1 second 2 meter. So this is uniform. And when it's moving random in 1 second 3 meter, 1 second 1 meter, and 1 second 2 meter, so random in each of the seconds, then it's non-uniform. Got it?
Yes, got it.
Yeah, nice. So now we'll go through variable. So variable is just again, I mean, it's unequal distance. Shinchan example. So we'll remember the Shinchan example.
Yes.
Okay. So unequal distance, but the time will be same. I mean, if he was initially moving 1 meter 1 second, 1 meter 1 second, now it'll be in 1 meter in 1 second. Then in the next 1 second, it'll be 2 meter. It will be random. That's variable, non-uniform, in equal interval of time. Now, if you see here, I've kept it the word as unequal, but the distance is equal. Got it? I mean, the distance is
Yeah.
unequal, but the time is equal. Here, the distance is also equal, and the time, of course, it was equal as it is. Okay. So now let's go with the average. This is new for you. What is this average speed? What is this average speed? Let's understand the average speed. So you know, I mean, do you watch cricket
No, sometimes.
sometimes? Do you know how to find the average run rate? Average when you see when you watch cricket, I mean, they show a slip kind of thing that average run rate of this over is this much, isn't it?
Mm-hmm.
So what happens? How to find it? Suppose bowler bowls the first ball, and he gets like from the batsman six. Second ball, how much you want? Tell me. Second ball, the batsman hits and how much run? Tell. How much?
Four,
Four. Third ball, now how much? How much?
six,
Six.
six, eight.
So you know in an over how much balls are there? In an over, six balls, isn't it?
Yes.
Yeah. Tell me in fourth ball, fifth ball, and sixth ball. Fast. Let me give it one, three, and he's out.
Five.
Out, out.
Oh,
How can it will five will be like somewhat different? You get a four and then you run or what? Okay, leave, no worries. So the procedure of finding average run rate is this: will sum of all the runs plus or scores you can say divided by number of balls. So when you find the average run rate, this will be 6 plus 4 plus 6 plus 1 plus 3 plus out means 0. Balls are number of balls are 6. So can you tell what the number is? 6, 7, 8, 9, 10, 20, 20 upon 6. So this gives you 3, 3.3 run rate. Is it okay?
yes.
So this is the average run rate. This is the way of finding the average. Similarly, for speed also, it's the same thing. Okay. So suppose particle is here at A point and he travels a random path, curved path like this and reaches here. So for this, the average speed will be total distance. In curved path, how will find the distance also? Is it okay? Total time taken. Is it okay, Arav?
Yes.
So from here to here, we'll trace like it's not. If we need to find a displacement, we'll find a direct linear distance. Is it okay?
Okay.
We have studied this that from in this thing, if we need to find a displacement, it's the straight line joining this. The path length of this AB is the displacement. But if we need to find a distance, it's all of this path length, which we am tracing here. Is it okay?
Yes, it's okay.
Nice. Now the last and the final type of speed is instantaneous. What is this instantaneous speed? Will
Instant speed?
instantaneous speed. Yeah, instant speed. Nice. Suppose you are having a butterfly. This is a butterfly kind of thing, and the flowers are there in the garden. A lot of flowers are there. So butterfly is flying this path. So if you're if you're having a camera, a high speed camera, and you just click here, so at this particular point, so it's somewhat like this speed at a particular point, at a particular instant, at a particular at a particular instant. Whatever the speed of the butterfly is, that is not an instantaneous speed. Okay. So
Okay.
yeah. So I mean, it happens like suppose you are traveling. We have the speed. Have you seen the speedometer? Have you seen the speedometer in your bikes? Let me show you the speedometer.
Yes, I have.
We have the GPS online speedometer. Nice. So this is a speedometer, isn't it?
Yeah.
Now let me start it. So you can see nothing is happening by the way. Somewhat maybe it's not moving. Okay, if I move my iPad, it will move somewhat maybe.
Okay.
But still not moving. No worries. Okay, we'll use some speedometer simulation maybe. Speedometer simulation. Simulator we are having. Okay, leave it. We'll use this. Okay, we can use somewhat random anywhere. Maybe it's available. Not available. Leave it. So I'll tell you why images. Yeah, we have the gaming
In
also.
cars.
In cars we have. Okay, let's see it. I need to discuss the paper also with you. Yes. So I'll not waste a lot of time here. What I'll do is this. I'll use some single speedometer here. Yeah, this is fine. So if we use this image, it will work. Let's move back. Let's move back fast. Okay, we have it here. Okay. So if you observe properly, you can see it that this thing. I mean, this screenshot is at particular instant. I mean, when the driver was like he was in the car and like car is moving at a particular instant, maybe they have given this screenshot. Okay, so you can see here that this needle points in this direction at this seven, somewhat near to 7.1 maybe. So that may be the speed at that time. And here, if we see, this is in meter per hour, and here it is maybe in the kilometer per hour. You can see. Is it okay? So it's written
Yes.
also 7.9 or somewhat like this 7. This is 10.2 miles and distance given. So this is all about the particular instant. So we can directly say at a particular instant the speed is, it is known as instantaneous speed. Okay.
Okay.
Yeah. So this is done. Now, Arav, I will fast discuss with you the paper which we have solved. Okay.
Okay.
Yeah. So here we are, and let's check it out. What was your performance? Fast, without wasting time. So here we go. So here I'm having here your answer sheet with me. Okay. So yes, let me send it to. This is your answer sheet. Okay. I'll explain you all the things, and it's just a test. Okay. Don't I mean we are learning from the test. Is it okay? How are you there?
Yes.
Nice. So I have given you few questions just for the practice, and these were 1 mark questions. Okay. So I'll use red color for this. Okay, fine. So first question I ask you, according to Newton's second law, the force is equals to what? So we know that force is equals to mass times acceleration. So your answer is this. Nice. So you got here 1 mark. Good. Then next question I asked you, mass of the body represent, you're giving me the amount of matter in the body. That's nice, 1 mark. Then weight of the object depends upon gravitational acceleration or distance travel. It's gravitational acceleration. That's nice. Actually, weight of the object depends upon. So weight we know. You know the formula of the weight, m into g. So you can say acceleration due to gravity. I must. Yeah, it's fine. So you get here 1 mark. Fourth, SI unit of force is Newton. Nice. You get 1 mark. Distance is a scalar quantity. Nice. You know the scalar vectors? Yes.
Yeah.
Displacement can be zero even if distance is not zero. That's nice. Good concept. I'll give you good if you understood it. Seven. The weight of the body is mg. Nice. 1 mark. Displacement can be zero when the distance is not zero. Displacement. Oh, no, 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 no. If acceleration increases, force will, of course, it will increase. Uh, Distance between the 2 points is actual path travel. Nice. So displacement between 2 points is shortest path travel. Nice. So you get here how much marks? Total of the marks you get here
And
is 10 marks. Nice. So you get here 10 marks. That's great. Let's move next. So now these are 2 marks questions. State Newton's second law of motion. The acceleration of the object is directly proportional to net force acting on body movement. Great out of great. Two. Define mass is the amount of matter in an object weight is the force of gravity acting on a nice 2 marks. So the differences where two differences between distance is total and displacement is shortest part. This is just a one difference. I told you right the two
oh,
difference.
two difference.
So differences like can be what? I mean that's fine. You'll get a 1 mark. But the second differences are like I mean you can just give an example also. You don't give an example, you just give a definition. So example can also be given. Okay.
Okay.
Yeah, that will give you 2 marks because one is for the definition and then for the example. Fourth now goes for the body of mass 4 kg and like acceleration 3 meter per second. This is Q 12 Newton force 2 marks. Nice. Now weight if we see that the y is the weight of the body more or less. The weight of the body represents the acceleration of gravity and this is yeah that's nice. And actually let me tell you for your information that on Earth we have weight mg. If we as the same mass go to the moon, this is weight on the Earth. Are you hearing? So that will be g by 6. Okay, remember this always. But for today, I'll give you 2 marks here because this is a thing. You understood? Yes or no?
Yes.
Okay,
Yeah.
nice. Now we have the next as so you get here 5 into 2, 10, but 1 mark is missing. So total you get 9 marks. Total you get 9 marks. So then we get 3 mark question, long answer. Explain the relation of the force, mass, acceleration, Newton's second law of motion. Okay, that's a full law given. Okay, okay, that's fine. So you get the 3 marks here. Now we have total distance. Student walk east, west, find distance. Okay, so you must draw the chart also. So this is north, south, west, east. So student goes 10 meter east, 10 meter east. Then he goes 5 meter west, 5 meter west. He reaches here actually. So again, he's from the origin, he's at 5 meter. So distance will be 15 meter and the displacement will be 5 meter. 5 meter, displacement will be 5 meter in the east direction. Nice, very good, awesome. 3 marks. Good. So third question will be a body mass 5 kg. That's fine. It's easy question actually. 3 marks. No worries. But for the 3 marks question, remember Arav, from the next time, if you're solving 3 marks question, see this type of question also came in the 2 marks question, isn't it? The 12 Newton force.
Yes.
For but for
Yes.
but for the long answer, you need to write the proper procedure. Like we know this thing, write these words. We know this thing. Force is equals to mass into acceleration, blah blah blah, and then solve the question. Okay.
Okay.
For now, 3 marks, it's fine. So total you have three into three, it's 9 marks total. So I will sum up. Sorry, I'm sorry for that. Again, the sheet came. Let me do it back. Again, the same sheet came, I think so. Yeah,
Yeah.
no worries in that. I'll maybe we can do something for that. I need to import some blank sheet here. Yeah. So you get the total marks here.
26 out of 30, I think.
Total marks 10 plus 9 plus 9. No, 10 plus, yeah, 10 plus 9 plus 9. And the maximum marks
26.
were 10 plus 10 plus, what was that? 9. So this is what 10 and you get it here is that like how much? What is that? 10, this is 28. And here you get it as how much? 29. Is it okay?
Yes.
Mm. So this is your score. That is 28. I'm sorry here. So you get the score as 28 out of 29. And I'll
Okay.
give you excellent because you performed very good. You missed an example. Things which were missing is this an example for distance and displacement to give the two differences. Okay?
Okay.
And the things to remember is for the 3 marks question, write more. Okay? So this
Yes.
sheet is going to be provided to you fast on your mail ID. So I'll send you the mail ID, okay, as we sent previously. So your mail
Okay.
was Rav. Okay, so this I'm sending you. So it's been sent now, I think so. Yeah, it's been sent. Now I'll move back to our notes. We were here. I'll send you the notes also, full-fledged notes on your mail ID. Okay,
Yes.
export the notes. It's been exported. Okay, Arav. Thank you so much for today's class. Okay,
Okay.
so I'm ending the notes. I'm ending the class, and then we'll send you the notes. Take care. Bye bye.
Bye.
Bye. Okay. This is again to Arav. It's been sent, I think so. Yeah. Let's export it to. Fine. So here was our class session now. Let me stop sharing the screen. So Arav, how did you like the class? Any doubts?
No. No doubt.
Okay. Okay, Arav, take care. I'm ending the class.